Hey everybody, Jeff Sky here, talking about weather model accuracy and whether climate change is actually making our weather forecasts less accurate. Here's an example, and actually the reason why I'm doing this video is in a 12-hour period. So today is August 4th, 2019. So from August 3rd at roughly 7 p.m. last night till this morning when I woke up, the forecast for the Philadelphia area changed dramatically. The whole 5-day, week-long forecast completely flipped. Now, weather models over the last 10 years or so, usually they've been really good in the 1, 2, 3 day time frame. It's usually 4 days out, 5 days out that things start to get inaccurate. But generally, weather models, especially for the mid-Atlantic, for mid-latitudes, they kind of know what they're doing, especially when you're 1, 2, 3 days out, they nail it pretty good. That has not been the case recently. So, for example, the forecast for August 3rd, 2019, for the 5-day forecast, so it's today, Sunday, August 4th through August 9th, that whole period said there were, out of those 5 days, there would never be a day with a chance of precipitation greater than 20%. So every day in that 5-day forecast was either 0%, 10%, or 20%. It uses 10% increments. Today, that forecast, so including the forecast for today from this morning, so the same 5-day period, only had one day that was 20%. The other 4 days were all 30 to 60% chance precipitation. So, like I said, we used to see forecasts change 4, 5, 6 days out. There's still a lot of variability the further out in time you get. But we're seeing an entire week forecast, including the day of the forecast all the way out through the end of the week, completely getting flipped. So we're seeing this instance of where weather models are actually getting less accurate. Now, this is anecdotal. You have to do more statistical analysis of whether this is really happening, but talking to other meteorologists and just people telling stories, they're like, wow, the forecast didn't call for any rain today, now it's pouring. So what's going on there? What's happening is, as these jet stream patterns break down, as the jet stream loses momentum from the differential of equatorial and polar temperatures, because the poles are getting warmer faster, the jet stream's losing energy, it's getting stuck. The problem is, when the jet stream gets stuck, whether it gets stuck here or whether it gets stuck there has a huge implication as to what a forecast will be for any given area. If you're on the trough or the ridge side of the jet stream, or even where you are within the flow itself, is going to have a huge implication on your temperature, your wind, your precipitation, everything. So what we're seeing here is the weather models are still running at the same full capacity that they always have been. The problem is that little small changes in where the jet stream gets stuck is going to have huge implications to the forecast. So the weather models might still be accurate sort of on a geospatial level, where they're like, okay, the jet stream might be here, but it might be kind of here. They've always done that. They've always said, well, the jet stream's approximately going to be here. But the thing is, back in the day when the jet stream moved more predictably and more fluidly, whether you were here or 100 miles over here, it didn't really matter, because the jet stream was so fluid, it was moving through and cycling things through so much faster that it didn't really have a huge implication on forecasts. The problem is, as the jet stream starts to break down, it gets stuck. Now all of a sudden, where that jet stream is, whether it's 100 miles over here or 100 miles over here, does have a huge implication, because it parks there and it stays there. And so, depending on which side of the line you're on, has a huge implication, whereas before it was a more fluid line. And so, whether you're on this side or that side didn't matter as much, because the line was moving more frequently. So as systems get stuck, weather models could theoretically become a lot less accurate, even if you have full computing power, because now small differences in global locations of weather systems magnify out much more than they did before, when systems move more fluidly. So just some food for thought. Once again, the reason for doing this video is because the weather forecast for Philadelphia for August 4th through August 9th, 2019, as of the 3rd, the night of the 3rd, called for that whole period to have no more than a 20% chance of precipitation, while on the morning of the 4th, we see that only one of those 5 days has a 20% chance of precipitation. No days have 0 or 10% chance of precipitation, and the remaining 4 out of 5 days have either somewhere between 30 and a 60% chance of precipitation, all being in the form of thunderstorms. So these are sort of the things that we're seeing as systems break down. It's not just a matter of sea level rise, and it's not just a matter of temperature change. It's an issue of unpredictability, and it's an issue of things getting stuck. That's where a lot of this danger lies. And the thing is, if you don't have fluidity in your system, and it's like spinning the wheel on Wheel of Fortune. You know, it's like, you know, the jackpot and lose all your money, you know, slot are right next to each other. You know, it's to be analogous. It's like 10 years ago that wheel was constantly spinning. You didn't really have to worry about where the Wheel of Fortune landed, what little sliver it landed on. But now, as the wheel's slowing down, which is happening with climate change, you know, exactly which sliver you land on, there could be two totally different slivers, you know, in the wheel right next to each other. And if the wheel's moving slowly, and you might have a really good sector and a really bad sector right next to each other, and it makes all the difference. So just some food for thought on weather model accuracy and how climate change is actually making weather models potentially less accurate.